Okay, let's go ahead and do transformations now, okay? Remember, the transformations will take place from our parent, right? Or our STD, A over X minus H plus K, okay? Let's go here. Woo, okay? Remember, we're comparing it to this little sucker here. So looks like there's no stretch, right? Looks like it hasn't shifted to the... Now, you'll see what this HK really mean on this case, okay? This HK has a special little meaning, okay? It's a 2 points, pretty much, that it cannot be, right? So here, in our case, 1 over x, so it hasn't been shifted, right? It goes through 0. But here, we have a k shift. That means it went down 3. Oh, so our HK really here is 0, 3, which tells us this, okay? Our vertical s, which means what's the x value that it cannot be? It's 0. And horizontal s, what's the horizontal value that it cannot be? It's negative 3. So y is equal to 3. Okay? So write that because this is what it really means. Okay? If we were to sketch this little sucker here, we start with the s's. X equals 0, so I'm going to go x equals 0, x equals 0, like this. That's our vertical asymptote. And y equals negative 3, right? Y equals negative 3, that means 1, 2, 3, and there it is. And you know what, you guys? You don't even need to, I just want you to sketch right now what this looks like. It's a transformation of our parent, right? 1 over x. And you know that 1 over x looks like this and this. So if it's been shifted down here, right? It's going to do the same shape, but it's going to go like this. See if you understand that. But all the other things are important. So you know the vertical asymptote, horizontal asymptote, our HK is that first point that it cannot be. Okay? It's shifted down 3, that's why. Now, let's actually tell me the domain and ranging, okay? Domain is what? Is there any x value that it cannot be? Yes, 0, right? So it's all reals except x cannot equal 0, okay? And how about the y value? It's all reals, right? Because it could go up and down forever, but the negative 3. But x cannot equal negative 3, so we have to state it that way. All right? So now go ahead and try number 20 on your own, and I'll show you 22 too. Try those on your own, okay? And I think the sketches really help. Why don't we go ahead and first do the HK, huh? Sorry, I dropped my marker because I was so excited. Okay, so HK, let's go to the HK first. What is your HK? 2, 5, good, okay? Now, tell me your vertical s and your horizontal s. Right here, like you said. Good. X is 2. That's a vertical s. Your horizontal s is y equals 5. Good. Okay? So that means if I want to sketch this, you should know what it looks like. X equals 2. X equals 2. Y equals 5. So it's moved up, huh? This graph. Okay? So you know it's going to look something like this. It's going to go this way and this way. And domain and range, domain would be all real numbers except 2. Range would be all real numbers except for 5. Do this one all on your own now. Stop the video. Welcome back! So HK, you should have written negative 6 and negative 1. Okay, who got that? Woo! Make some noise. Vertical s and horizontal s. Vertical s, x equals negative 6. Horizontal s, y equals negative 1. If you got this right, give your neighbor a high five. Woo! Okay? Now, domain and range. Domain, all reals except that x cannot equal negative 6. Range, all reals except what? Y cannot equal negative 1. Okay, just make sure that you have that. And ask me questions when I return, okay? I'm right now at EcoGeo, right? Now, sketch asymptotes and graph the function. State the domain and range of number 20. So this one is going to be the big one, okay? We're going to sketchy. Now, have you identified the domain arranging? HK? I think we've been doing this, but this one's nice and big, so we'll just finish this one, okay? Oh, we already did that, you guys. Right? It's transformed to the right 2, up 5. That means that vertical and horizontal asymptotes have been shifted. I'm sorry about this one. Okay? What if I ask you this question? Where is the sky undefined? Undefined. You're right. At 2, 5, right? Undefined at 2, 5, right? So you know it's going to go 1, 2, 1, 2, 3, 4, 5. Here's the horizontal. Here's the vertical. Okay? Okay, but you know, let me show you a way to graph this exactly. What if I ask you, I want you to graph exactly, like exactly, totally, okay? So I'm going to show you to do that. The way we've been doing it in class the whole year, okay? So here, you know how we go, our classic is -3, -2, 1, 2, 3. And we do -1/3, -1/2, -1, undefined. We do 1, 1/2, 1/3. You know how we do that? Well, what if we had to make transformations, right? What if we had to make transformations? Let's do it the same exact way. Let's be consistent, okay? What are the transformations that took place? Okay? Well, let's actually not even write this line. Don't we always do this, you guys? Oh, let's erase that, okay? Don't we always go, okay, here, x has been, didn't it go right 2? So x plus 2, yeah? Sorry, I don't want to put that. Okay, x plus 2. How about the y value? What's happened to every y value? It's moved up 5. So we know it's y plus 5. Okay? All right, so it's y plus 2. So why don't we just do that for each of these, okay? -3 became, plus 2 is going to become what? -1. And here, it's just going to become 4 2/3 because we add -1/3 and 5. So go ahead and finish the rest of the coordinates. You should have got this. I'm putting a star there because you know 2, 5, it's undefined, okay? And here, oh, so 3. Check if you have these coordinates. Remember, I'm just applying the same transformations so I can be consistent with the way we've been graphing in class. All right, now you graph this exactly the way you see it, and this is how you get the exact graph. Because we have a vertical asymptote at 2, right? And we have a horizontal asymptote at 5, like this. And these are the points of this. Try graphing it, okay? Okay, I think you should be good for